Welcome everybody to this week's Azure and AI show. And we have some new speakers with us today. We have Dan Ray with us again, one of the founders of the Azure and AI show. Dan is with us here from Chicago. And we have Emmy, and he's going to do a session on responsible AI in the age of foundational models. And then up next, we'll have Chandrayee. She'll be doing a session on the observability gap, understanding silent failures in AI systems. And also then we have Sasha. He's going to do a session on human in the loop for generative AI, building reliable systems. And then we have Mason will be following with his session on exploring the Dataverse MCP servers. So we've got a lot of topics there. So, Emmy, do you want to share your screen there with us?
Yes, I'm sharing my screen now. Thank you very much, Frank.
Okay.
Please confirm you can see my screen.
1 second there now. Yep, there we go. You can see it there now, responsible AI in the
Okay,
phone.
so I'm going to be looking through here so that I ensure that everybody is seeing what I'm displaying. So once again, thank you very much, Frank, and thank you everybody for being here. My name is Ime Iyang from Nigeria, and I'm the founder of Expert Technologies Limited. And our interest is in bringing AI knowledge to the younger generation. We're looking at um, primary education and secondary education, particularly getting them ready for the uh, the rapid development in artificial intelligence at the tertiary level. So that's a simple background about me. And our topic today is on responsible AI in the age of foundational models. And that phrase alone raises an important question. What does responsible AI actually look like in practice? So, for many teams, responsible AI sounds abstract. It often feels disconnected from day to day engineering work. But foundation models are changing that. And I'm going to show that in a bit. So today, developers are building co-pilots, conversational assistants, enterprise search systems, and AI-powered workflows directly into production applications, right? And as adoption accelerates, the challenge is no longer simply accessing powerful models. I mean, with DeepSeek here and the continuous iterations of ChatGPT, we see that power is no longer a dream, it's a reality. But the real challenge is building systems that remain trustworthy when these models behave unpredictably. That is why I want to approach this topic through a practical engineering lens. Instead of treating responsible AI as only policy of governance, we can explore how trust can be intentionally designed in AI systems from the beginning. And that idea is what we call trust by design. And trust by design is not only it's not a term that is unique to artificial intelligence, is a term that is unique in software development in fact. Okay, so when we talk about trust by design, we're even talking about data trust, particularly. So let's begin with a simple but uncomfortable reality. So foundational models are incredibly good at sounding intelligent. And that's part of what makes them powerful and at the same time dangerous. So, an AI assistant can confidently provide a completely incorrect answer. Like then when AI search was recently launched into Google search, and people ask questions like, "How many stones a day can I eat?" And the model, there are pictures of that conversation that the model responded, "Oh, you can take about 7 stones a day and you'll be okay." you know, as compared to how many apples a day you can have. So that's what makes them dangerous. And an assistant can confidently provide a completely incorrect answer and fabricate the information or follow instructions that it should actually ignore and yet sound very convincing about all that. And when we embed these models into enterprise applications, customer support systems, co-pilots, or whatever, the impact becomes much larger. And the challenge is that many users naturally associate confidence with reliability, which is a challenge we have, especially with the younger generation, because they have come to be exposed. They are born in a time where AI is in charge, right? They do less Googling and they just do it straight in either Gemini or they do it in ChatGPT. They do not allow themselves the opportunity to do some research. It's something we also find with some of our learners, all right, that they should not associate confidence with reliability. And traditional software either works or fails visibly, but foundation models can fail invisibly. What do I mean by that? Here's an example. How many of us have seen an AI give us an answer about food, maybe an answer about food or distance? It gave you it gave you a wrong answer, but it gave the answer confidently. I believe we've all had that kind of experience, even with measurements, right? Before tools were really a thing, you could ask ChatGPT about measurements, and it's going to falsify the value for you and be very confident about it. Now, that behavior changes or should change how we think about software quality, testing, and trust, right? And one of the biggest mistakes organizations make is treating foundation model systems like traditional software. While traditional systems are deterministic, large language models are probabilistic. It's not about, it's not really about there is a particular output that we are looking for. It's about, is it close to what the user is wanting? Because as we understand, it's all about probability. So um, LLMs depend on context, phrasing, retrieval information, system instructions, history, conversation history, and sometimes randomness. And this means that the engineering principles we will practice when dealing with large language models must evolve. We are no longer building purely true false systems. We are dealing with probabilistic systems, and so our approach should also be probabilistic. It's going to change, and we'll be talking about testing, monitoring, validation, governance, and user expectations. And this shift is why responsible AI can no longer be treated as a separate compliance conversation. It has to be part of engineering itself. So we are no longer dealing with um, just API failures and downtimes. We are dealing with hallucination, manipulated prompts, unsafe outputs, just like the situations of the cases about suicide. I think This year, I think it was the beginning of this year, in I think England, there was also another case of someone using one of these language models to guide it somewhat into suicide. So, a particular important concept about about this challenge or this behavioral risk that we are faced with LLMs is prompt injection. While in traditional systems, users usually cannot rewrite application behavior using plain language. In LLMs is different. Prompts themselves become a part of the attack surface, and that is it shows a major architectural shift. And because these systems are conversational and adaptive, failures can sometimes appear subtle rather than catastrophic. And the challenge is not simply preventing AI from saying harmful things. The challenge is engineering systems that remain reliable under unpredictable outcomes. So many organizations may respond to this risk with quick fixes. And while some techniques actually are helpful, the challenge is dealing with one particular technique as a solve it all or a master key for all your problems is not the best way to handle it. For example, thinking about system prompts as the best way to handle user inputs or use model responses is not going to work. Why? Because we understand that system prompts sit at the top of the context window. And so as the conversation enlarges, as the conversation widens, the model tends to drift in its behavior, right? So you cannot trust system prompts. Then you talk about lowering temperature to control randomness. It may work, but it doesn't mean that it's going to solve the situation of false information. And then you have RAG. If you implement RAG, then RAG is going to handle hallucination. Well, that's true. RAG can control hallucination, but it doesn't completely eliminate it because even with RAG, your pipeline, either your pipeline or your documents, your source document can be poisoned. So that cannot be the final formula for making LLM systems safe. Or if you consider content filtering, right, to help prevent harmful outputs, you can't guarantee that the output is truthful or reliable. So it's a dangerous assumption to believe that just one technique does all the good. Trustworthy AI systems require defense in depth. All right, so the question uh, that we should be asking ourselves is how many safeguards do we currently implement in our AI workflow, especially at production level? And it matters because modern AI systems fail in layers, and that means trust must also be built layer by layer. So this brings us to the central idea of this session, which is trust by design. So trustworthy AI systems are not created accidentally. They are intentionally designed using layered safeguards that work together. So instead of relying on one perfect prompt or one filtering mechanism, we build multiple layers of protection and validation throughout the system lifecycle. And we can call it a trust stack, right? Each layer addresses a different category of risk. One layer addresses controlling inputs, grounding outputs, filtering unsafe behavior, monitoring system performance, and ensuring human oversight when necessary. So we have The first two layers include intent control and grounding. So here we would be dealing with system prompts, limiting user instructions and validating inputs and restricting sensitive actions. So uh, something like this. I saw something like this recently in ChatGPT and I think ChatGPT and Claude. I saw something similar to that. I was trying to build synthetic data around uh, suicide, suicide notes. Right. I just wanted to generate something to do a kind of semantic analysis about it, but it was unsuccessful. Why? Because the model quickly flagged that request as a bad request and said, I'm sorry, I can't help you with that. So that's one way we can do that by restricting, validating inputs and restricting sensitive actions. And then for grounding, we have RAG systems, which we've talked about, which allow the models to retrieve trusted information before generating output. So, but something we should remember about retrieval augmented generation is that it reduces hallucination risk, but it does not eliminate it. So, uh, grounding must itself be designed carefully. Another layer is safety and observability. Safety controls will help reduce harmful or unsafe outputs, and this can include moderation systems, structured response formats, output validation, and content filtering. And traditional monitoring focuses on metrics like uptime, latency, and throughput. But for AI systems, it requires behavioral monitoring. So we need visibility into how prompts evolve, how output drifts over time, and where hallucination typically occurs, and how users interact with the system. So there are still situations where humans must remain involved because not every AI decision should be fully autonomous. So, for high risk scenarios, especially in healthcare and finance and legal systems, it often requires escalation paths and human review. So, this is where governance becomes practical rather than theoretical. And this can include approval workflows, escalation systems, or red team testing. So, the goal of responsible AI is not perfection. The goal is just control, uh, observable and accountable behavior. So um, Azure is well positioned for enterprise AI because it provides many of the building blocks needed for operational trust. Azure OpenAI uh, provides secure model access. Then it has content safety for which helps moderate harmful content, and monitor and application insights for observability, and a rule-based access and manage identity to help control. So our takeaway as I end it here is prompts are useful, but they are not security guarantees. RAG improves grounding, but trustworthy systems still require validation and oversight. And responsible AI is not achieved through one single feature or service, but it emerges from layered engineering decision workflows together. And foundational model systems are dynamic, which means that every evaluation and monitoring must also be continuous. So, just a closing reflection, which is we may not train foundational models ourselves, but we are still responsible for the systems we build around them. So, trust is everything. Trust is everything, and let our engineering reflect trust or trustworthiness. Thank you very much.
Thank you, Amy. Great presentation there. Very clear and straight to the point. We we just have one person there on the thing. No questions, but he says, nice work. If you can see that on the screen there. Any questions from anybody? Okay, so we also have Hal joining us this week. Hal, welcome. Hal is a Microsoft MVP. He's been an MVP for 30 years now, is that right, Hal?
Yep, 30 years.
Very good.
Hard to believe.
Thank you for your
Here we are.
service.
Respect.
So we have Chandrayee. Do you want to share your screen with us?
Sure.
Okay. Okay. we
Is
can
it
see-
visible?
Yeah, visible.
Okay. Okay, let me start from here. Good afternoon, good evening, everyone. Let me briefly introduce myself first. Okay, I'm Chandrayee Kumar. I have over a decade of IT experience, and besides, I also take interest in research area, like as an independent researcher. So before starting today's formal presentation, let me ask you a question. Like, as an AI engineer, we often face this kind of questions. Like, how many of you have deployed an AI system in production? And if yes, how confident are we whether the system is behaving correctly or not? So it's not just about the servers up or running, whether the AI is making the system the right decision or not. So that's the gap between knowing your infrastructure is healthy and knowing your AI is actually working. This is what I call as observability gap, and today I want to show you why this is one of the most underestimated risks in modern AI development. So, my current research is focused on formal monitoring frameworks on multi agent AI systems, building the tool that detects failure before they becomes a disaster. So today we will cover what the gap is, why multi-agent system make it worse, and what the research community has built close to it. So let me go to the next slide. Okay, this is here. Okay. So every team I speak with has the same kind of setup, right? They have the same dashboard showing the CPU health, the API latencies, the HTTP status code. Everything seems perfect because everything is green and feels safe, right? So they are here. These matrices are real and important, but they answer one question, that is the system running? They cannot answer the question that actually matters for AI. Well, is the system reasoning correctly? There is the fundamental category error in how we think about AI monitoring. We borrowed our system for observability tools from traditional software, like tools designed for deterministic systems, But in AI, like as we all know, AI systems are not non-deterministic. So system does not follow an idempotent workflows. The same input can produce different output over the times, because an AI agent, like an agent can return the plausibly looking answers, but that is completely wrong sometimes, and it still gives you a 200 code. So on the very left side, if you see here, I have jotted down the points what we can measure, and on the right hand side, what we cannot see. And in between, the gap is between these two columns, that is the exactly observability gap. To understand why this gap is so dangerous, we need to understand what the modern AI system looks like. Here comes the next slide. So let me describe what an AI system actually look like in production. Like you have agent 1 responsible for data retrieval, maybe using a vector DB or a normal web search tool. Its output feeds to the agent 2, a large language model that reasons over the data. AI2 passes its analysis to the third layer, like that is the agent 3, a decision making module, and so on and so forth. It comes to the agent 4, and that is the action layer, which writes to the database, sends an email, or cater to any downstream services. Now, here is a critical insight. Each of these arrows between these layer like agents, that actually is a trust boundary. The agent 2 trusts that the agent 1 gives a correct data, and agent 3 trusts the same has the same trust from the agent 2. So there is no inbuilt verification at any of those hands off. So here comes the three key points, that is the non-determinism. Unlike the traditional software, you cannot see, like you cannot just write a unit test cases on top of this, like given input X will always produce an input Y, output Y, right? Because LLM are probabilistic by design. Compositional failure is the next term. That is, a small error in the early in the pipeline does not stay small because it gets amplified and reinterpreted at each step. Next is the no shared data state. Like each agent is isolated, the system has no global view of what is happening across the full trajectory. So, what is the exactly observability gap, and how do we define it formally? Let me give you a precise definition of what we are dealing with right now. The observability gap is the structural disconnect between what infrastructure monitoring can measure and what the AI system is actually doing. The space where silent features live, propagate, and compound without triggering any alert. I want to emphasize on the word structural. This is not a tooling problem you can solve by adding more dashboards, but rather than it's a more on the fundamental side, like it's a fundamental architectural gap between two kinds of observability. On the very left hand side, if you see, is the zone one, that is the infrastructure observability. This is where your existing tool lives, like Prometheus, Datadog, CloudWatch, and these are excellent at what they do. But they only see the hardware and the network layer, and the gap in between, in the shadow. This is where the actual AI operates. The agent handoffs, the non-deterministic reasoning path, the semantic correctness, business logic adherence, none of these are visible to the zone one. And on the very right hand side, if you see, this is the zone two. On the right, that is a business reality. What is this level? This zone is doing, like, this is what we actually care about, right? The are the decision correct? Are the user being harmed, or is the business logic is being followed? So you only find out about the failure here after the damage is completely done. So the research question that motivates in my work is to how do we build the monitoring infrastructure that span over these three zones, and that we can see into this gap. Coming to the next slide. So before we can monitor for the silent failure, we need to understand what they actually look like. So I have identified four distinct modes of multi-agent, probably the most common ones in the multi-agent system. One is the semantic drift. This is slow but gradual kind. The model does not suddenly break, rather it drifts. Each individual output seems reasonable, but over the time the behavior diverges from what was intended. One you only notice when you look at the full trajectory, not the individual outputs of each agent. Next is a very common for LLM, that is the hallucination propagation. This is unique to the LLM based agent, and like a language model that generates confident, well formatted, completely wrong answer sometimes. The next agent in the pipeline has no way to know what is wrong and the reason on top of that the error. The third agent reasons on top of that, and by the time you see the final output, the original hallucination is buried under this three layer of plausible sounding reasoning. Next is the contract violations. Every AI agent system implicit business rules, like maybe never approach a loan above this threshold without a human review, or in healthcare system never recommend a treatment without the confidence score is above 90%. So these are the rules that is written in documentation but not in the code. And when an agent violates them, nothing breaks because no exception is raised. The fourth is the emergent failure. This is the most subtle and the most dangerous, maybe, because each individual agent is working correctly. The failure appears when you look at the interaction pattern between the agents. This is why you cannot monitor an agent in isolation. And IBM research validated that XGBoost and the trajectory features achieved most 98% accuracy detecting these failures, but you need the right feature to extract, right? So this brings to the critical risk. I want to spend a moment because on why this is not an academic curiosity, rather why it matters in the real world scenario, like in the tech world, like wherever we are working. So the first thing is the financial risk. When an AI agent automates a decision at scale, like pricing, trading, lending, a single failure affects million transactions in milliseconds. The damage is order of magnitude greater than any human error. Next is the safety and compliance risk. In the regulated industry, a silent failing agent can violate compliances rule that audit logs still read as system healthy, but the consequences are not just technical, rather they're more on the legal and the ethical side. And third is the trust erosion. Every silent failure discovered after the fact reduces the confidence in AI system. The organization respond by pulling back the AI autonomy, reversing the very efficiently gained that justified the deployment. So the IBM research qualified this gap precisely with the trajectory level monitoring. Looking at the full sequence of the agent action and the output, 98% failures are detectable. But with infrastructure monitor alone, the number is essentially zero that you can see here. The tools exist, but the question is whether we are using them. This brings to my the next slide, that is the solution framework, that is the FAME framework. The IEEE research community has been working on this problem, the FAME framework, the formal assurance and the monitoring environment. It represents one of the most rigorous approaches to the production in AI monitoring. The formal contracts. FAME uses a mathematical rule written in signal temporal logic, not just the informal guidelines. So it's STL. What it does is like it lets you express the precise behavioral constraint, such as output must be stay within the range. Like if A happens, then B must follow within the next n steps. Not the exact matching, rather than the deterministic, the probable distribution match. Um, Next is the runtime checking. These rules are checked continuously against every live output. So the monitor sits between the AI model and the rest of the system. If a rule is violated, an alert fires immediately. And third is the independent monitoring. The monitor does not rely on the model's own confidence score, rather, it applies external deterministic rule, which is exactly why it catches the failure model itself it cannot see. So that brings to the bigger picture, or more into a specific design problem, that is the multi-agent monitoring. So my research contribution is FAME, then extension of this FAME framework, especially designed for multi-agent system. The core insight is that you cannot monitor a multi-agent system with a single monitor. You need to monitor at three level of abstraction. Let me walk you through this three layer that I have defined here. On the left hand side, in the layer one, that is the I'm sorry, that is the intra agent monitoring. This is the closest to the original framework. Each agent has its own formal contracts, a dedicated monitor to check whether the contract continuously, and if agent 2, the reasoning LLM, starts producing the output with low confidence or start drifting a little from its expected output distribution, the layer 1 catches it. Next comes the layer 2, the inter-agent contract monitoring. This is a novel contribution. At every handoff point between the agents, we define a contract that specified what valid data looks like. When agent 1 passes the data to the agent 2 and the layer 2 monitor checks, does this satisfy the agent 2's input contract? This is where we catch the current unit type error. Maybe in a currency, instead of USD, you are sending a pound. So that is something we can catch in this level, or the format mismatches and the semantic incompatibilities, of course. And the layer 3 is the global trajectory monitoring. This is the highest level of abstraction. We look at the full sequence of actions and output across all agents, the complete trajectory of a task from start to finish. So, this is where we detect the emergent failure, the feedback loops, the cyclical patterns, the aggregate drift. And on the right hand side, we have the full diagram of the entire FEMME architecture. Yeah, so this is the next slide, which I call as a layer 4 monitoring stack. Let me translate the research into the practical implementation roadmap. So let me walk you through the bottommost layer, that is the layer 1. This is the infrastructure layer. The server metrics, the uptime, APM tool, every team has it. It catches the hardware and the network failure, not the AI behavioral failure. In the layer 2 is the model behavior. Like what it catches, like statistical monitoring from input and output distribution. It catches the distributional shift, and when the production data starts looking different from the training data. Some teams have it, but most of them do not. Layer 3 is a semantic logic. The formal contracts that encodes the business rules catches violation that looks statistically normal but breaks the business logic. This is where the FAME layer 1 and 2 operates. The critical is almost universally missing. And the last layer is the layer 4, the trajectory. The full sequence analysis of all agent interaction catches the emergent failure invisible at the individual agent level. This is a research frontier, like where the if FAME layer 3 and the XGBoost layer analysis operates. So layer 1 and layer 2 are necessary but not sufficient, but layer 3 and layer 4 where the real observability gap lives and where the research community is now focused. Coming back to the last slide, let me close with the three concrete takeaways. Like, what is the takeaway from this entire discussion? Like, first is a monitor behavior, not just infrastructure. Knowing the server is running is not enough, because semantic and trajectory monitoring in the layer 3 and layer 4 needs to be become as a standard as CPU monitoring, especially as AI system grows more autonomous. Second, second is the adopt formal contracts for AI. Like signal temporal logic is not abstract theory, it is the practical tool for encoding business rules that can be checked automatically at runtime. The FAME framework has already demonstrated this work in production. And the third is think in trajectories, not in snapshot. Like most dangerous failures in multi-agent system emerges from agent interaction, not from the single agent, not from any single agent rather than. So monitoring individual agent is not enough. The full trajectory must be observed, and the observability gap is real, present in every production multi-agent AI systems today. But it's not inevitable. The IEEE and IBM and the broader research community has built the foundation. This work with FAME-MA extends those foundations specifically to the multi-agent context. The tool exists, the frameworks are validated. Now we need to think of whether we need to adopt or not. With that, I want to end my slide here. Thank you.
Thank you very much. Great job. We don't have any questions coming in on this side here, but anybody any questions? Looks like you're off the hook. No questions. Okay.
Thank you.
It is great to see the other side of AI from just using it, and from what you're telling us in the background, it's great to kind of see that's going on as well. So we have Sasha. Do you want to share your screen there?
Yes. 1 second.
Okay, there we can see it, human in the loop for generative AI.
Yes. Perfect. Perfect. Cool. Let's get started. Hello, all. My name is Sriharsha. I'm a senior business engineer at Meta. And I sincerely thank Frank, Dan, for providing this opportunity to be on this show. And just a quick disclaimer that whatever that I'm going to speak about, this human in the loop generative AI, has nothing to do with my job at Meta. This is more of my personal work and research that I have done on my own, along with one of my friends here. And this work is kind of related to the patent I already have in terms of that is very much relevant to human in the loop for generative AI and also GraphRag. With that being said, let's get started into it. So I just want to start with a simple question like, what makes AI trustworthy? We are living in an extraordinary moment, right? So where large language models can write code, draft legal briefs, generate photorealistic images. So systems like text to image create artwork that wins competitions these days, right? So and multimodals reason across text, images, and audio simultaneously. But most of the times, like, here is what we don't talk enough. So these systems do hallucinate, like Amy was saying earlier. So they fabricate stuff, they exhibit bias, they produce outputs that look confident, but they are fundamentally not right. And in high stake domains like healthcare, financial services, safety critical engineering, that gap between impressive and reliable is where the real damage actually happens. So what bridges that gap? The answer is both surprisingly simple and technically profound. It's humans. So not humans replacing AI, not AI replacing humans, but humans working with AI in carefully designed collaboration loops. So what we found is that human in the loop systems achieve an average around like 40+% performance improvement across Gen AI applications. And the architecture of that collaboration, how you design that loop, determines everything. So let me walk you through what we discovered. So the number 40.7% average performance improvement. That's not a rounding error, so that's not a marginal optimization as well. So when you integrate human expertise into Gen AI workflows at the right points and in the right ways, you get transformative gains. Is what we have come up with after researching around like 200 plus papers. So, but averages only tell a part of the story, right? So let's look at the range here. So on the lower end, it's 0.2%. That's surgical, highly targeted intervention. So maybe a single label change in training pipeline. And at the high end, it is 121%, literally more than doubling the actual performance. So that's what happens when you redesign an entire feedback loop around human judgment. So the median is around like 19.2%. So think of it practically, right? So half of all human in the loop implementation in the research papers that we have studied, around 200 plus. So nearly saw 20% or better improvement. So if someone offered us a 20% improvement in accuracy, efficiency, and quality in your production systems, you would take that call immediately, right? So that's a no-brainer deal there. So now the national question is like, what separates the 0.2% from the 121%? What makes some human in the loop implementations transformative and others marginal? That's exactly what this review unpacks. And the answer starts with understanding why AI alone falls short. So let's talk about the problem first. So let's ground this in reality. So Gen AI, large language models, text to image systems, multimodal architectures, they have created unprecedented opportunities for automated content creation and decision support. So what is in dispute is whether they are ready to operate independently in high stake environments or not. So the research identifies three fundamental failure modes actually. So the first one is hallucinations. These systems fabricate facts, right? With the same confidence they state true ones. So in an actual enterprise settings, say like a financial services chatbot or a healthcare decision support tool, that's not just embarrassing; it's dangerous too. Second, bias and misalignment. So the output often don't match what actually the users see. The the system sometimes exhibit biases inherited from the training data. So they might miss contextual nuance that any domain expert would catch immediately by looking at the response. So third one is inconsistent quality. So you run the same prompt 10 times and get wildly different quality levels. So that unprecedentability makes production deployments genuinely risky without human intervention or human looking at the quality of the outputs there. So our review's theoretical foundation rests on a core insight that I think is underappreciated at the moment, which is like AI systems, despite their impressive capabilities, fundamentally lack things humans bring naturally, right? So the contextual understanding, domain expertise, and common sense reasoning. This is something that humans bring to the board, and human feedback provides this training signal that is qualitatively different from and richer than what most of the automated metrics can actually capture. So this doesn't mean actually the AI is broken. It just means that AI is incomplete at the moment, and HITL is how we complete it. The question is, how do you design that collaboration? So let's talk about the framework on how we could design that system. So how does the human in the loop actually works? So the review reveals that human intervention happens along three temporal dimensions, and the most effective systems leverage all the three dimensions. So that is before generation, during generation, and after generation. Let's go one by one. So before generation, what does that mean? It is basically a pre-generation guidance. So this is where humans set the stage, like prompt engineering, designing domain specific ontologies, establishing constraints as well. So the ChatGPT based framework for a missionary functional safety platform, for example, found that design of prompts significantly affect initial accuracy. So longer, more detailed prompts improved the first pass accuracy, while shorter prompts work better for iterative refinement. So that's the design choice that they made when I was reading that particular paper there. And the second framework is during the generation. So it's called like in process steering. So this is a iterative refinement loop. So research on text to image generation showed that when users can adjust prompts based on the generated outputs, and that creates a feedback loop, and you get significant improvements in both subjective and quantitative measures of alignment. The key insight here is it's not just editing, it's more of like collaborative approach there. The human and the AI are converging on a solution to get a better output. And the third one is after the generation, so post generation validation. So quality assessment, expert review, error corrections. So this is where the domain expertise matter a lot. So if you remember, I was talking about the machinery safety framework in the before generation part. So the same framework achieved complete agreement with ground truth through iterative expert feedback, adhering to the ISO standards after having all this quality assessments and error corrections being fed into the systems. And the critical nuance is the review highlights, right? So the feedback granularity matters a lot. The spectrum ranges from simple binary just like accept reject decisions or thumbs up thumbs down decisions or something, all the way to rich structured annotations marking specific problematic regions and attributes there. So one such example I can give you is think of rich HF 18K dataset. So this is a dataset that is widely used for text to image generation. So this is the dataset they use to actually train these models. So they have seen marking implausible images, image regions, and all, and identifying misaligned text, annotating misrepresented prompt words. So all this information they just feed it back to the trained models to predict uh, what's missing in the current systems, and that would actually help the system to generate a better output. So what I meant to say was like the richer the human signal and the feedback is, the system learns the better. uh, I would like to actually deep dive into one of the model in the loop. So this is like a framework system that is relevant to the human in the loop system, and there are multiple of such frameworks, but this is something that caught my eye, and I would like to discuss more about it in this particular slide. So let me take you inside this system. And we call it as the Milo system or Milo framework, so model in the loop. So it's one of the most thoroughly evaluated systems in the review that we have conducted, and it works in a collaborative paradigm. So if you see in the first step, you see that unlabeled data. So unlabeled multimodal data enters the pipeline. So nothing unusual there. So the second step is where the system gets kicked in. So LLMs serve as a pre-annotation assistants. So they generate initial suggestions and run consistency checks, but they are not the final authority to sign off anything. Step three, human annotations and decision makers. So human annotators here sits in the third step, and they are the final decision makers. The system is explicitly designed so that humans retain decision authority. The LLM just suggests, the human is who that decides. And the interface is designed to minimize cognitive load so that contextual information is presented clearly, and structured interfaces reduce decision fatigue. Coming to the fourth one, quality rubrics. So quality assurance is something that we always need for any system that we build, right? QA scores use point deduction and grading scale rubrics with head-to-head comparison between helpfulness and honesty. So this isn't a vague feedback that we are going to feed the system in. It's actually a structured, quantifiable, and actionable feedback that we are going to feed the system. The results of around like 30 empirical studies we have made, what we have seen is like reduced handling time, and it improved data quality. So that last one matters more than you might think. If your human in the loop system burns out your annotators, you have traded short-term quality for long-term impact. But here's what I find most insightful about this particular MLO framework. So it also identifies its own limitations. The framework explicitly notes reliance on fine-tuned smaller models with potential for suboptimal for performance. The need for improved inference time for real-time assistance, and crucially the lack of comprehensive studies on human modeling collaboration designs. So this is what the intellectual honesty brings in when you actually add the human in the loop here. So the key principle here is design the loop so that humans and AI each work and do what they are good at. AI provides speed, consistency, and initial structure. Humans provide judgment, context, and authority here. I would also like to talk about giving you an example on how the text to SQL things work with human in the loop system. So this is a different HITL architecture solving a very different problem. Okay. So, and this one hits close to home for anyone working in enterprise environments. So text to SQL is something that sounds straightforward, right? So a user asks a question in a natural language, AI generates a database query. But the thing is, in enterprise environments, this is actually one of the hardest problem in applied AI, because you got vast schemas, sometimes thousands of tables. So ambiguous terminology where the same word means different things in different contexts in different tables, and the cost of errors is high. A wrong query in financial services doesn't just give you a bad answer, it gives you a wrong answer that looks right. That's the worse than no answer at all, right? So having a wrong answer is always bad than having no answer. So, and the other thing is the LangGraph based framework addresses this through something called stateful graph orchestration. So what it does is, instead of treating text to SQL as a single modal call, it decomposes complex queries into specialized agent tasks, and these get connected through a stateful graph structure. But here's the HITL design insight here. Human validators are actually embedded at strategic checkpoints. So they confirm the data sources, they verify the query logic, they intervene when the automated components encounter ambiguity or high stakes decisions. And the graph structure itself serves as the HITL purpose here. So it provides transparency into the reasoning process so that the validators can see not just what the system decided, but also they can see why the system has decided on a specific decision there. That transparency is what builds trust, and trust is what it drives the adoption here. So the case studies across financial services, healthcare, and e-commerce all showed the same pattern: improved accuracy, enhanced user trust, and increased adoption compared to end-to-end approaches. So the hybrid human AI approach just don't perform better, it gets used more actually. So, and a system that people trust enough to actually use beats a technically superior system that sits on a shelf. So I would like to provide some evidence across multiple domains here. So let's look at the evidence map here. So HITL improvements aren't just confined to one modality. They span everything from text to speech to 3D modeling. So let's go one by one. So in text and natural language processing, we use it for label replacement. So a targeted human intervention in LLM generated training data is increased absolute. So that increased absolutely across. So it's 1.4, sorry, 14.4% there. So that's a single specific human correction scaling across an entire data set. The missionary safety framework I was talking in the previous slides, which was using ChatGPT with HITL, used 4.9 out of 5 for time efficiency and 4.7 out of 5 for overall accuracy across 4 industrial case studies there. And for text to SQL, as we just discussed, the hybrid approach outperformed end-to-end alternative across several enterprise domains. So if you remember, I was talking about the rich HF 18K dataset, right? So that is used for image and visual models. So here is the finding, and that should get your attention here actually. So improvements generalized beyond the models used for data collection, and the feedback on stable diffusion variants improved generation in Muse, a completely different architecture. So for 3D model generation, code level prompts with HITL achieved perfect reconstruction across all the metrics, such as volumetric accuracy, surface alignment, dimensional fidelity, and topological intricacy. Coming to the speech modality, in speech, there is a thing called HL star GAN. So it's like human in the loop star GAN. So it is a specialized generative adversarial network framework designed for unsupervised face mask speech enhancement. So it aims to transform muffled, distorted speech recorded behind a face mask into high quality, clear speech systems. So this system integrates a human aligned quality predictor, the mask QSS. So it is actually developed with human participants. So it outperformed both conventional star GAN and cycle GAN based systems in face mask speech enhancement across 3 mask scenarios plus clean conditions there. So what I meant to say here from this slide is the pattern is unmistakable. So HITL works across every modality because the underlying principle is universal there. Human judgment complements machine capability. So let's talk about the 3 pillars of HITL evaluation. The first one is quantitative metrics. So traditional benchmarks like accuracy, alignment scores, efficiency measurements, task specific metrics, all these come under this quantitative metrics here. So in a safety domain, ChatGPT with human in the loop scored around 4.95 and 4.7 out of 5 on overall accuracy, like discussed in the previous slide. So for 3D model generation, the metric suite included volumetric accuracy, surface alignment, dimensional fidelity, and topological intricacy. And code level prompts with HITL achieved perfect reconstruction of all of them. So pillar 2 is going to be human evaluation, like I stated, structured user studies, expert panels, scale assessments, etc. come under this pillar. So the machinery safety framework that I discussed earlier, we got an ground truth of 100% alignment with the experts based on the day-to-day experience they have in working in that particular industry, and we just compared that experience with the output that we got from the models there. So the Milo framework uses quality rubrics with point deduction and grading scales, validated throughout the expert researcher feedback and other agreement rates. So the pillar 3 comes to reference-free methods. And this is where the field is heading to, is what I understood from reviewing all those papers. So these don't require ground truth at all. So LLM-based evaluation metrics like GEval and Prometheus demonstrated reliability closely aligned with human evaluation. So the mask QSS predictor for speech enhancement successfully predicted human quality judgments. And the rich HF 18K dataset I was talking about works perfectly well in multimodal transformers to automatically predict human detailed feedback. So this convergence towards reference-free evaluation aligned with human judgment is, I think, one of the most promising directions in the field. And it's how we make HITL scalable, by teaching machines to approximate the human judgments and decisions at evaluation time, not just at the generation time. So these are the 6 best practices that work in production. So if you're deploying HLD systems in production, the review distills 6 practices that have been validated in real world enterprise settings. First thing is agile feedback driven system. So the Adobe Summit Concierge AI proved that you don't need the perfect data to launch. Combining prompt engineering, retrieval grounding, and lightweight human validation enabled a scalable, reliable AI assistant, even in a cold start scenario with data sparsity. So the lesson learned there is start with human in the loop and iterate. Don't wait for the perfect product launch or automation there. Second is hybrid automation strategy. So this is the pattern we see in usual enterprise CRM systems. So AI handles the routine volume, human agents handle the complex and sensitive cases. But the architecture demands sophisticated routing logic and seamless handoff transitions. So get get that routing wrong, and you frustrate not just humans but also the customers. So third one is quality engineering framework. So the unique challenge with Gen AI is its non-determinism. So the same input can produce several different outputs there. So traditional software testing does not actually apply cleanly here. You need HITL specific testing protocols that account for visibility here. Fourth one, strategic validation checkpoints. So LangGraph text to SQL systems embed human validation at data source confirmation and query logic verification. So these checkpoints are especially critical in applications where errors have downstream consequences. Coming to the continuous monitoring. So don't treat HITL as a one-time quality gate. Embed collaborative annotation workflows into production monitoring. The enterprise AI research assistant shows that this HITL enables early detection and incident prevention, and you catch problems before they even reach the users there. And coming to the last one, it is expert integration. So invest in your human experts, recruit them, train them, and retain them. The missionary safety framework explicitly calls out the critical role of expert oversight. So your human experts aren't a bottleneck to optimize away. They are the quality signal that makes everything else work better. So let me bring us full circle to the question I opened with. What makes AI trustworthy? So around 200 plus papers, 40.7% average improvement, a range from 0.2 to 121%. Evidence across text, image, speech, 3D, and multimodal systems. Five distinct feedback architectures, four integration patterns, three evaluation pillars, and five critical gaps that remain unsolved is what we have talked here. And throughout all of it, one conclusion stands clear. So, well designed human in the loop systems represent the most powerful approach we have for achieving reliable, high quality, and trustworthy Gen AI. This isn't about, humans versus machines. That framing was always wrong. It's about humans with machines. It's about designing the collaboration, the architecture of the loop, so that the every partner that contributes in the system do what they do the best. AI brings scale, speed, and consistency. Human brings judgment, context, and accountability. So what I would like to say as a part of this presentation is the most powerful AI systems in the world still need us, not as a crutch, not as a stopgap, but as an essential permanent designed in component of systems that actually work. The question going forward isn't whether to include humans in the loop, it's how to design that loop so it's effective, scalable, sustainable, and ethical. Thank you so much for this opportunity.
Very good, very good.
Thank you.
Great stuff. I'm just looking here. We don't have any questions coming in from the internet, but have any of you guys any questions? All quiet. Very good.
Cool.
So we have the LinkedIn. If anyone else has any questions for you, we can put them into LinkedIn.
Sure thing.
Sure, great job. Mason, do you want to share your screen?
Yes.
Okay,
My
there
audio.
we can see it.
Sure. Thank you so much for all the sessions. That was really nice, and actually to see all other side of the AI, what Frank was mentioning. That's really nice because there are a lot of things going on in the backend, and we are just using them. It's good to know. And my name is Maysam. Actually, I am Power Platform and Dynamics Customer Engagement Solution Architect and MCT. Actually, I was confusing with MCP. Today, I'm going to talk about MCP servers and what is exactly this protocol that everybody's talking about it. In previous session, we had some actual introduction about it, but today I'm going to show you in the system how we can explore and how we can use it in the Power Platform. Before dive into the system, I just wanted to show you quickly one slide that's what is exactly MCP and how it's working. Actually, it's the MCP is stand for Model Context Protocol, is a open standard that let's helping to the AI models securely connect to the different systems. Like if we have different AI models, our system can connect, our legacy system can connect to that AI models without re-implementing again that connectors. So MCP helps to the AI to connect easily, send and receive data securely, and translate at the end all the responses to the shape that AI like it. And we can see actually the difference between API and MCP is like API is like a doorway to the system that you are consuming and using it, but MCP is a standard way that AI use those to actually consume APIs and understand the system and help us to use that system with natural language. In the structure, if you want to see here, the Dataverse MCP server, I will use one Copilot agent and will use the MCP client that it's connected to the Dataverse MCP server, and in the backend, that server it's connecting to the Dataverse, and we can actually use for creating records or tables and different stuff there. So let me open the system here. I have a Power Platform environment here, and there are different components there, but we will work mostly with tables here. And in every Power Platform environment, you need to first enable this MCP server. For enabling it, you need to go to the admin center.
So we're not seeing that screen now. We're still seeing the first screen.
Sorry, just a second. Okay. Let me share it again.
Okay, we can see that now.
Okay, so let me go back. So I have a Power Platform environment that there are different stuff here like tables, flows, etc. But for enabling MCP server on my Power Platform environment, I need to go to the admin center and to actually the environment that I have inside the environment and setting, product and features. There are two options that we need to enable. The first is this one that we need to check mark. And the second one is in this list. We need to enable actually Microsoft Copilot. We need to enable this one, this option here. After enabling it, if we create a new agent, I just created a new agent. Before, in the old solutions, before MCP, I would say, for every single step, we needed to add new topics, we needed to add new flows to create a record, to change something in the system. But with the MCP, what we are going to do is we will add these tools. After enabling it, we will add these tools here in the list of the MCP servers. We have actually Dataverse MCP server here. I already added to the system, so I will not add it again. After adding it, this will automatically configure and understand all the system, all the structure, all the schema, all the tables, everything. And if we open it in the tools, here in the tools list, we can see what functionality we are going to use, and we have it there. We can, for example, list all the tables in the system, or we can ask to describe one table, or read data, or create tables, update, delete. All these actually tools are built in the system after adding this MCP server. And the good part is it's understanding whole the system, and we don't need to, as I mentioned, we don't need to create for every new table when we are expanding our system. We don't need to create new flow for that. It will understand automatically. Let's try some of them, like give me it's automatically querying to the system and giving you how many tables you have, especially if you have, for example, give me, you have the custom tables. So you see I have here 5 custom tables. I want to create a order. Okay, so you should, the list of the queries or tools are here, and when you are actually calling them, you need to fill some information like test order and existing account contact ID. So let me open up here. And go back to I'm not giving the customer name because I need to check it. So if I go to the here to the order list. Okay, so because I put it in a inactive, just a second. Order 1. Okay, so let me refresh it. Yeah, I have it here now. So I just created this order with this MCP server without doing so much effort or opening the form or whatever. And let's check other commands or other things. Give me list of accounts, for example. I would like to see my account list here, like this one. Editor. I will open it, and I would like to say, for example, update oops, sorry. To this one. And if I refresh page here, I see that the data is updating successfully. Also, yeah, for deleting, for the doing other, using other tools, we can use them here. And also, if we want to create our own MCP servers, that is another subject. But here, I want to use more in a schema of the system. For example, I want to ask, give me list of the apps in the system. How many apps there are in the system? There are different applications. You see, even in the system, in the schema or in the structure of the system, you can have, if you have access, admin access, you can actually see what applications are there and have more detail of them. And also this MCP servers respecting to the security and the hierarchy and permission of the tables that you have in the system. If someone has less access, they will see the records accordingly to their access and respecting to their access. Let me do something like give me list of orders. Okay, like stuff chart and see what is going to do for us. Yeah, like you can play with the commands and prompts with different things, and this MCP server in between, it's understanding the system, exactly what is in our dataverse, what are the data, what the system is doing exactly, and in other hand is using the AI, connecting to the AI, and it can communicate between them and use this. Also, you see it's actually offering me to have export Excel. I don't want to use it, or like give me full detail of this, full detail of this account. Yeah, and we did the update, and we can try this one. Now, because I have the admin access, I can delete this record, but for sure you can, when you have in Dataverse, we have hierarchy security, we have row level security, we have different kind of security and security roles. So if you are actually denying something, for sure they will not be able to delete or do something here. This is an asking. And if I go back, I see my record is deleted. You see now, for all the tools that we are using for creating a table, we didn't test the table yet, creating a record, reading actually the record, updating, fetching, all of these tools. Before MCP, you needed to do separate, you need to implement separately with flows, with the different APIs, different things. But with MCP, you have all this package in one, actually in one server, and you are just calling and using it, right? It will change a lot, in my opinion. All the, the agent creation, all the words that we are using to implement all the AI agents, etc. So this is kind of the short demo of the Dataverse MCP server. Let's try to create a table. For example, feedback table. I will not provide any more detail. I'm just saying feedback. Let's see what it's going to do, because for sure it's connected to the AI. It will think, and depend of the name that I'm providing, it should be smart. It will take some time, because in the backend, if you want to create a table, for sure you need to go to the setting, create a new table, and then add your fields there. It will take some time. So that is the reason it's calling the Dataverse API now, using that endpoint to create this table for us. So you see that I just provided name, but the feedback table is created by title, comment, and you see there are different type of fields in Dataverse, and it's automatically and smart. It's actually choosing them, like the title is a string, comments multi-line, rating is integer, etc. For sure, we can change or add a column subject string to this table. Before this MCP, if you wanted to expand the system, for sure you needed the citizen developers to add more fields, etc. there. But here, okay, so let's go to the tables, all, and I believe we will have one more feedback because one of them is this one. It's a custom one. If I open it, I want to see last modify is 2 minutes ago because we just created it there. So here I can see maybe the what was the message? With a new column subject. Please insert some dummy data for this day. I'm just adding some different because it's something we're gonna. Okay. Yes. Okay. So tables. Why we don't have it here? Same environment. Okay, into the list. Okay. Let me just quickly add this table, my app. Both. Yeah, here we have it. So just deleting this table. Yes. Oh, not this one. Okay. It's confusing because we have two tables. Mm-hmm. Need to say exactly which one. So now this MCP server, you can use this one in other tools too, right? You can add to your actually Visual Studio, for example. You can add whenever you need to use it, and it will be smart like this. No, it can understand your system. It can understand your commands. You can do whatever you want in your actually system. Oh, okay. Now the table is deleted. We could easily create new table, delete, add field, and read data, list all the tables, see what's going on in the system, in the applications with the Dataverse MCP servers. And yeah, that was, and also we can publish this for sure, this agent, anywhere that we want. That was all from my end.
Good job. At least you got it to work. These live demos can be horrific. Sometimes they could go wrong. But yeah, you got it working in the end. That's great. Any questions from anyone for Mason? No, everyone is very quiet tonight. No questions. So we have Stephen after joining us there. And
Thank you.
thanks, Mason.
Thank you for the opportunity.
Okay, all right. Thank you very much, Frank. 1 second. Let me just quickly upload my slide. One second. Okay. Yep. I think I should be good to go now. Yeah, I think my slide is coming up the next seconds. It's taking time.
There we
Okay.
go.
Yeah, cool. All right. Thank you. Good evening, everyone. Yeah, my name is Apoyemi Steven. You can call me Steven. That's fine. So today I'm going to be talking about enabling the Microsoft Entra service, self-service password reset. This is now the password write back. The last time I talked about the SSPR, so which I did in the Microsoft Entra ID. So now I'm going to be talking about the password write back, which is on-prem environment. So thanks. Now the service the self-service password reset, which is known as the which is in the Microsoft Entra, which allows user to reset their password using the web browser. So on the web browser, they can actually reset their password and then unlock their account without admin intervention. So let's assume a user account who is from on-prem, and then now the user in the cloud account get locked, so they can actually unlock their account, and then also we have the allow to update credential from any device anywhere, reduce help desk call volume significantly. Then if you look at from research, you can see that this self-service password has reduced the whole lot of help desk admin tags by 70%. So it reduces that call, which means that users can actually reset their password on their own without the help of the admin, so that and without the help of the help desk, so they can be productive in other things. And the service is always on 247, so it's always available. It's not like, oh, once the IT is closed, then you can't reset password. That can be done at any time. So that's for that. Now, this password write back. It's a password write back synchronizes password changes made in Microsoft Entra ID back to your on-prem, which is the Active Directory domain services environment in real time. So we have zero delay sync. So the password changes sync back to on-prem instantly with real-time feedback. And then we have the policy enforcement. So on the on-prem environment, so you have the password policy, complexity, history, age. All these are being enforced completely, and it's known as the bidirectional, which works password, which password hash sync through password through an AD federation services. Okay, so all these are password write back works with all this. And then we know how this password write back, how it works. User initiates, which means that user requests to reset their password or change password via the SSPR portal. And then two, it now the Entra ID processes this particular changes. So it's now password encrypted with public key and sent to service bus. They now have connect receive. So now it now connect, which is the Entra ID, pick up the changes from the service bus relay. Then the AD, which is the Active Directory domain services, now get updated. So password written to on-premises AD after policy validation. So which is supported hybrid identity model. We have the password hash synchronization, we have the password pass-through authentication, and then the Active Directory Federation services. Now, this password write back security model. Now, encryption take place. Now, which says that the password that you've been changed, the password that is written from the on-prem to the cloud, is not being saved in the Entra ID. This password is encrypted, so it's not in a plain text format. So which non-admin can see it. So no admin can see anybody password is being encrypted, and there is a secure channel. This password are not stored anywhere. Like I said, it's firewall friendly. There's no bound. There's no inbound firewall rule that disrupt any communication. So this password write back will sync effectively as long as it's being configured properly. Then we have the prerequisite, which is and the licensing. So we have the required license, which you must have the Microsoft Entra ID P1 or P2, and then we have the Enterprise Mobility plus E3 or E5 licenses, and then we have the M365. So, and then we have the Microsoft 365 Business Premium, and then the infrastructure requirements, which is the on-prem AD environment. So you must have your Microsoft Entra Connect, we are the current version, or the Cloud Sync agent, and then you have the hybrid identity admin or global admin account. So means that must that be a global admin account to be able to configure that. And then you have the SSPR already configured in Microsoft Entra ID. So in between your Microsoft Entra ID, there's a configuration that has to be done already. Then before you come to the on-prem environment, and then you configure that. Then the domain controller on supported Windows server. Okay, so it has to be on the Windows server environment. Now, let me just walk you through that step manually here before we go to the portal to be able to configure that. Now, to configure your AD account permission, now grant the Entra ID Connect services the necessary permission in Active Directory, which means that when you open your Active Directory computer and user, so the advanced feature must enable, which is your view. So that view enable you to see some particular settings that need to be configured properly. Okay, so on the admin, on your on-prem environment, when you get there, you go to your domain, the root, right click on the security advanced, then all these has to be applied. So which now all these settings are settings that needs to be configured for you to be able to have that password right back configured successfully. Okay, and then if you look at let me go to next. Then the next thing, you now enable the password right back in your Entra Connect. So which now in your Entra Connect environment, which is the agent has to be installed, must be in your on-prem environment. So you sign in with you sign in with your global admin account. So you see the welcome screen, you click on the configure, then you select customize synchronization option, and then you click on next. Now, before you do that, you must enter your hybrid identity administrator credential, or if you are a global administrator, so you enter those credentials, and then you can click on next through, then you follow those steps to be able to configure the password right back. Then you come up here, you see that option, password right back. So that will now be configured. Now, next one, the next one, which is, okay, let me click on next. Okay, now the next one, you sign into your Entra ID, which is your Entra ID admin environment, and then you now navigate to your identity, which is known as the Entra ID protection, where you have the password reset. You go to the password reset option, you go to click on premises integration, and then you can now enable write back password with Entra Connect, and then also allow user to unlock account without resetting their password. So which means that when user account get locked, so this option also needs to be enabled in your Entra environment, and then you click on save. Then the next one, on your on-prem environment, you have to go and set where you have the your group policy. So you have to go and set the password age, the password policy. So it has to be set to the minimum password age. Okay, so you have to set it to that one. So when you come up here, you set that. Now, when you come up here, you have to set that minimum password age. It has to be what on? Sorry, it has to be on 0. Okay, so that has to be set on that. Then the next one here, that's okay. This is just the step to do that. Then the next one, you now go to your Microsoft Entra Cloud Sync, which is known as the lightweight agent. So this one must also be configured in your in your on-prem environment. Okay, so you have to make sure you download that agent and get it configured on your Entra environment, your on-prem environment, before you can use that. Now we have the Cloud Sync prerequisite, and then the agent setup. Now the Cloud Sync, on your Cloud Sync, you must have the Cloud Sync agent installed in your on-prem environment, and then ensure that you already have the Entra ID license, which is either P1 or P2, and then you must be either a global admin or a hybrid identity. Okay, so if you are not a hybrid identity, if you don't have that role, you might not be able to configure the write back policy more. Maybe you can only just configure the SSPR, which is normal or in the cloud, but this one is both on the cloud and then on the on-prem environment. So you must have this particular permission to be able to do that particular role. So you must have that particular role. Then you enable the Entra ID stuff, and then this one, the agent has to be installed in your server, in your on-prem environment. The agent, so this agent has to be installed. If the agent is not being installed in your Entra ID environment, you will see that it's not communicating. So it will tell you that it is not being set up, so or it's not enabled. So which means that has to be enabled. So it must talk to your on-prem, it must talk to your Entra ID environment. So once it talks that, once they can talk to each other, then you can be able to configure your password right back effectively. And then the next one, you have to enable password right back. So you come up here, enable the password, you configure your authentication method, which I think I spoke about this in the last section I did. And then you go to your enable on-prem integration, where you can now enable the password right back. Then you configure, then you verify that the agent station, the agent the status is now being as verify. Then the set password policy age must be set in your on-prem environment so that this can work effectively. Then the last thing, you now need to verification and testing. So you have to verify on your on-prem integration, which is your intra environments. You use to verify that all these testing are being enabled. Then test with a sync user before you can now deploy to a wider group. So you need to test with a sync user. Then confirm that the ADS is updated, which means that when a user reset their password, when you reset the password, go to the attribute and then check under, because by then you'll have configured this password last reset attribute. So you need to go and check that attribute to make sure that it's showing that the password was actually right back. Maybe it's working effectively. Maybe, for example, somebody reset their password today, and then you now go to the user attribute, and then this password, you now check this password last set. You can see the attribute is still showing maybe like a month ago, and the person said, I just did it now. So that's telling you that this is not being configured properly. So it must show that read date that, okay, this user said this, reset the password and it's working. And then that can also help you for your troubleshooting issue. Then event log is also very important. So whenever you have an issue, the event log is the first place to visit to see what is happening if peradventure a user are not able to reset their password. So event log is very important. Then next we now have run data sync. Now this data sync is very, very important. It's good because when a user, let's say for example, let's say I'm doing a test now and I want that user to sync immediately. I want that to sync immediately because normally when you configure this thing, it's always good you leave the policy to run themselves, so you don't force the policy immediately, because that's why when you are designing your environment, it's not something you just design and you feel, oh, users now have to jump in and start making use of. No, that policy, they take time to sync. So it's really very important in the production environment that you leave policy to sync on their own. But in a case where we are testing, I want to see that this policy that we did is working effectively, then we can now run this data sync. Okay, so this data sync will tell you if the password write back is being synced properly, if there's any error or not. So it's always good to use the data sync, but in a real ideal situation, you leave that policy to sync on its own. Then you have some troubleshooting, some common issue you find when you are troubleshooting, because this syncing password write back is very, very important, and at times some people find it so difficult to say, oh, what is happening, oh, this, why. So troubleshooting, you must also have that troubleshooting knowledge to understand what is not working if users are facing any issue at the end of the day. But like I said, it's always good to do a test run, test it on a set of users. Especially most organizations can say, okay, let's test this on some set of IT, maybe like, let's say the help desk or some set of IT people. After we see that, okay, it's effectively, then they can now run it to maybe like to the HR department, thereabouts, run it to the finance department, and then before you can now run it to the wider reach. But before then, it should have been sent out to the user to notify them that this has been set. So these are common troubleshooting error where we have the password reset succeed in cloud but not written back. So which means that you have to check the password minimum age in your group policy. Okay, so that has to be checked. Then you have on-premise integration show not enabled. In a case where you say, oh, I've enabled this, oh, I've installed the agent or something like that, because if you just have the cloud sync installed and you don't have the agent, the agent is not being provisioned, then on the intra ID environment, you will see that it will show that not enabled. So it must show that status is enabled. So in a case where you're having this, then you have to rerun the intra connect wizard. Okay, you have to run that and make sure that it works properly. Then user gets, let's say for example, you have user gets could not reset password error. So you need to verify password, user password meets on-prem AD complexity requirement, check AD local status in AD and things like that. Then we have the cloud sync agent showing unhealthy. So which means that you have to restart. I think I did a video on that. You can restart the Microsoft Azure AD provisioning agent to verify the network, and then make sure that. So these are some common troubleshooting error you can do if you configure your password right back and this is not working effectively. And then these are common, these are the key takeaway. We'll talk about the password right back, the 4-tier security model, 2 method, which is known as the cloud sync lightweight. And then we have the require proper AD permission. We must have the require licensing, which is either P1 or P2. And then this minimal password age must be set to 0. It's quite very, very important. Okay. And then always test with a sync user account and verify via attribute and event log. Okay. So I think that is all for now. So I'm just going to jump to the portal and just show. So what I did was that I've configured this. I've configured it because of time and also because it takes time to sync through the on-prem environment. So I've configured it that way. I'm just going to walk you through on how this is being configured. But what I've done before, I've configured it and it's running properly on my environment. I'll just walk you through so you can see that. So now I'm just going to stop this and I'll share my slide. I'll share my screen. 1 second. The 1 second. I think I'll share screen. Okay. Share screen. Just want to be sure I'm sharing the right screen. No. Give me 1 second. Okay. Can you see my screen?
No, just the old one.
Okay. Okay. I think I need to stop that one. Okay. Let me just remove this. Remove from stage. Okay. Okay. Stop sharing. Let me share again. Let's share my screen. Entire screen. And then, yep. I think you should be able to see my screen now. Okay. You able to see my screen?
Yeah.
Okay. So you can see my admin environment, right?
Yeah.
All right. Okay. So now this is my admin portal. So you go to your normal admin portal, normal admin.cloud.microsoft. So under here, I'll come up here. I'll now click on my identity, which is my Entra ID. Okay. Click on identity, Entra ID. Now this is my. So now this takes me to my Entra ID environment here. So now in this Entra ID environment here now, like I said, I've configured part of the SSPR, which is the last time I was here. So you come up here and click on your password reset. But I usually like to make sure all these things are being collapsed so that for somebody who is just watching, don't get confused. So this is how the environment will be if it's being collapsed. So you have favorite, you have Entra ID, you have ID protection, ID governance. So you come to your Entra ID, okay, so that you don't get confused. So when you come to your Entra ID, you come up here and then click on the password reset. Okay, click on password reset. So now when I click on my password reset here, the last time I apply that on a set of group of people, but this time around, I'm also syncing my user from on-prem to the M365 environment. So here I leave this one as all. Okay, I set it as all. But if you are testing for just some set of user, you can decide to say, or maybe you want to do some selection. But for now, I'll click on all. The authentication method here, we set our authentication method with the numbers of authentication required to reset the password. We choose 2, which is mobile phone and security questions. Okay, mobile phone and security questions, and then numbers of questions required to register, which is 3 questions, and number of questions required to reset 3 questions. And like I said the last time I was here, I said by which is here, I don't know if you can see from here being highlighted, it said security questions are retired in May 2027. So by March 2027, security questions will be retired. So which means that this option will no longer be there. Okay, so Microsoft is retiring that by 2027. All right, so you come up here, and here I configure my security questions here. So you click on that, you choose the option you need to choose, and then I come up here under the registration. Under registration, you come up here, you have require users to register when signing in. Okay, so I'll click on yes, and then number of days 180. It depends on the company policy. I think this 180 should be at 6 months or so. So you can configure how you want it to be. So then notification, you come up here. Who do I want to get notified? Yes, users to get notified when their password is being reset. Yes. Now notify all admin. No. So you don't block them with messages. Okay. So admin will always work with their logs and then check whatever is happening there. So this option is set to no. But like I said, depending on organization policy. So some organization can just say, okay, yes, and then maybe they just put one admin there and needs to be doing that. So then customization here, under this customization, you can decide to say yes, and then put a link here where the users can maybe just go click on it and then do their password reset. But normally, you might not. This can just maybe for just or rebranding and things like that. So you can use that option if you want to. Now, this is where we are now going to now, which I'm talking about, which is the on-premises integration. You click on here. Now, under this on-premise integration, now that is the password write back I'm talking about, which I've talked about. Now, that is for that. I'll come back to that. Now, this audit log, I usually forget this audit log, so I don't forget before because of rushing. So your audit log here, this is your audit log. This audit log is very, very important as an admin, because when you come to this audit log here, you will see history of everything that has happened in this particular environment. You can see now all the self-service password have been done. You know, if you click on it, you can see some I tested today. You can see showing that it was successful. Users successfully reset their password. This one here, you can see successful complete resets. You know, so audit log is very, very important, which allows you to see what is happening in that environment. Okay, so I'll go back to my on-premises integration. Now, under this on-premise integration here, like I said earlier on, I've configured this because of time. I don't want to take time, and then it also takes time to get sync so that we'll see how it works. Okay, now under this place here now, what are the configuration you need to do here now? Under you have manage settings. Now you must ensure that enable password write back for sync users is being enabled. Okay, so that option must be enabled. So ensure that this option is being enabled, is being ticked. And then you have the write back password with Microsoft Entra Connect Cloud Sync. Okay, this one too must be enabled. Okay, you have to enable this, and then you have allow user to unlock accounts without resetting their password. You know, at times maybe a user, maybe let's say they use the wrong password maybe multiple times and their account get locked, and then suddenly they just remember, oh, I think I can remember my password. I have this password. I want to use it. So they have that ability to unlock their account, okay? So without them resetting their password. So maybe because they've tried multiple passwords, maybe multiple times, and their account is locked, and now they suddenly say, okay, I can remember the password, so they can unlock their account. So this option must be selected when you are configuring your password right back, okay? So these three options has to be configured. So okay, so it must be selected. Now after that, you can see here you have your Microsoft Entra Connect Sync agent, and you have the Microsoft Entra Connect Provisioning Agent Cloud Sync. Now these two agents, these two software, you must have it on your on-prem environment. So it must be configured in your on-prem environment. If it's not configured, that's where you now see that you see this status. It will say not enabled. Here it's showing me setup complete, because like I said, I've done that. Okay, I've configured it. If you click on your details shows you different things, the server and everything like that. Can you see that? So which means that it's configured already. Okay, so that option is configured. So if you are seeing that this one is saying not configured, then it simply means that your password right back is not going to work. So you have to ensure that this one is showing that it is configured. And how do we do that? Now on my on-prem environment, now I'm going to switch over. Please let me know if you can see my screen. Can you see
my
server?
Yeah.
All right, thank you. All right, okay, so this is my on-prem environment. Okay, this is the server here. Okay, now let me close this. I'm just gonna minimize this. I'll close this one. Now if you look at this place now, this is my server. This is my Windows Server 2025. Okay, now on your window, which is installed, it's on my hypervisor environment. So here, this is your Azure. Here is showing as Azure AD Connect, but it's known as the Microsoft Entra ID Connect. Okay, so in case when you see that in the exam, so you don't say it Azure, so it has been changed as the Microsoft Entra ID. But when you download the agent and install, this is what's going to be showing you. So it means that maybe Microsoft is still yet to update that. So nevertheless, it's still doing what it's meant to do. Now, so that is for that. Now, when you come, once this is being installed, now this now allows you to now communicate. This now allows your users to sync to your on-prem environment. Now, your on-prem environment, so any user you have to sync to your Microsoft 365 environment, any user you have in this your on-prem environment will sync to our Microsoft 365 environment, which actually I have a user here. If I come up here now, here, if I go to my tools and I click on my Active Directory users and computer, now under this place here now, if you look at it now, this is my domain environment. So look at this, my OU. I have different organization units here. I have the HR, I have the sales, I have the security teams. Okay, this is my OU. Okay, this is my organization unit. Now, if you look at this place now, under this sales, now I have this user called Kate Johnson. Now, Kate Johnson is synced to my M365 environment. If I go back to my M365 environment here, if I come up here, let me go to this admin environment here. I'll come up here, I'll locate my active users and come up here and then look for that user. Let me just type the name of that user, Kate. So you can see now, you can see Kate Johnson. Can you see that now? This user is now in my M365 environment, but this user is coming from here. Can you see that? This user is coming from here with the help of this particular app, this one, which is your Microsoft. You can see it's written there as Microsoft Entra Connect Sync. Okay, so this is what enables my users from on-prem to sync to my M365 environment. Okay, so that's why you can see if you come up here under your sync status here, you can see here is showing that by the time you point at this place, it's showing that is sync from on-premises. Okay, so this is being synced from on-premises. Okay, so I just want to show you that. Now let me go back to my server. Now, when you do that, here you come up here. Okay, before that, let me just create a user. quickly because I'll come up here. I will create a user. I'll come here. I'll click on this user. Let me just create one user. Let me see which user can I use because of time. Screen can have a lot of users. Also, I have what is it called? License to give to this user. Okay, let me just say screen. I'm just going to just pardon me name I'm using for now. All right, so here I'll come up here. I'll take a screen. That's the name of the user. Screen.good. Okay, so that is my user logon. Okay, so in your organization, naming convention too is very, very important. Some organizations will use first name dot last name. Some might just use just initial, and then so it depends. And then this is my domain here. I'll click on that, and I'll click on my next. Here I'll now come up here. I'll create my password. I'll create the password for that user. Come up here. I'll now create that password again. Now I don't want the password to be changed. I don't want to just uncheck that. So yeah, I can say, okay, password never expire. Let me just click on that option. Then click on your next and click on finish. Now, this user has been configured. Now, this user has been created in my on-prem environment. Now, for this user to be able to sync here, for this user to come here, so syncing must take place. Let me refresh. Syncing must take place in your agent. And this syncing is usually done faster. So let me just come up here. You might be surprised that the user is already synced. Okay, it's not yet synced. So I'll come up here. So for this user to be able to sync, I'll come up here. Here, this is my agent. This is what I need. The Microsoft Entra Connect Sync. Okay. Now I'll click on configure. Now, once you click on configure, you now come up here. You click on your customize synchronization option. You click on your next. Then here you put in your username. Here, this is your global admin account. Okay. So if you are a global admin account, depend on, or maybe you are just an hybrid identity admin. So you must come up here and put that credential here. So you come up here and click on your next. So once you click on next, then come up here, you put your you enter your password. Okay. So this password is your global administrator password. Okay. So click on sign in, and then it should authenticate. Okay, my authenticator. I'll go on my phone and then click on the matching number. 1 second. Yeah, matching number, which is 46. So you can see now it said connect. You can see how it's doing faster. It's connecting from my on-prem to my M365 environment. So they are trying to talk to each other. So here, this is my forest, which is my domain. You can see that now. So it's yemtechit.com, and it's the same thing as my on-prem environment. So if you are using local.com, it will not sync. So they must comprehend, because so the domain is very, very important. I think that's another topic, another talk for another day. So here I'll just come up and click on my next. Then here, domain and OU filter. So here I can decide, okay, sync all domain and OU, or I want to select. You can come up here and say select sync selected domain and OU. Okay, if you come up here, then you can come up here and then select which of the OU you want to sync. Okay, but in this regard, I want to sync all my domain and the OU. Okay, so I'll click on that first option. Okay, so I will now click on next. Now, when you now click on your next here, now you can see that you have your password hash synchronization is being checked. So that particular option has to be checked so that that user I created on my on-prem environment will now be able to reflect in my Microsoft 365 environment, and then I can now test the SSPR password right back on it. Okay, I'll click on my next. Then you can see it's checking for install components. So this will go and go and go and go. And just to make you to understand that this is a server that is not being turned off. So like, you know, so because if you turn on the server, once the server is in shut down, so it will not communicate. So no sync will take place. So take note that this is a server that you don't shut it down. Okay. So now you come up here, it says start the synchronization process when configuration complete. Yes, configured. Then you can see it's now communicating, and then that user should be able to sync to my environment immediately. But if it doesn't sync, then I can now use the Delta sync to be able to sync it faster to my M365 environment. Okay. So let's wait while this is taking place. Yeah, so. And don't forget that your server also has to be connected. It must be talking to the internet. Okay, so it depends on what needs to be configured. Okay, so I can see my server is connected to my host machine internet. So that's why it's able to communicate with my M365 environment. Okay. So you can see configuration complete. Say the configuration is complete now. So now I can now click on my exit. Now let me now go back to my M365 environment here. And now I will now search for that user, and then I can now issue license to that user. So here, active user, the name of that user is screen, enter. Now, can you see that now? So the user has been synced to my M365 environment. Can you see that this user is now synced to my M365 environment? But this user is coming from the on-prem environment. So, but without that particular, without your Microsoft Entra sync, this will not be possible. Okay, so let me see if I have license to give to this user. Let me see, just wait me 1 second. I think I should still have one more license. I'll come up here. Okay, I think I have one more. So lucky. So here I will give this user this license. I'll click on save. Click on save. Now remember that this user is coming from on-prem. Now I can use the password of that user from on-prem to log in as normal user in the cloud environment. Okay, because the password as sync from the on-prem to the Microsoft Entra ID. But like I said, it's not sync in a plain text. I can't see the password. No admin can see the password. It's always encrypted. Okay, so that's for that. Microsoft can also not see your password. All right. So now I've issued license to this user. So now let me try to, okay, let me just leave that. I'll come back to that. So now that is for that. Okay, now open my the user. I'll come up here, open this place. Now that's for that. Now remember that we have configured the password right back in our Entra ID environment here. This has been configured. Okay, now on the on-prem environment here, now when you come to this, before you come to this one now, before you open this and configure this, now this particular one, which is known as the Microsoft Entra Provisioning Agent Wizard, must be also what installed. How do you get it? You go to your Entra ID environment. You go to Entra ID environment. You come up here as an agent. You come up here, and then when you come up here, you click on your Entra Connect. Click on Entra Connect. On your Entra Connect, you now have the cloud sync. You can see that you have here. You click on this, then you now come to agent. Then you can now download that agent on the on-premises environment. You can see, but because I've done it, you can see it's showing there. So you download this one on your on-prem environment, and then you now install that agent. Okay. So once you now do that, now I'm going to open this one. I'll double click. Now, here you say, welcome to the Microsoft Entra Provisioning Agent configuration. Okay. Now you click on your next. Like I said, I've configured that before. Here, it will now ask you to connect Microsoft Entra ID. enter the credentials of an administrator in Microsoft Entra ID with permission to manage provisioning agent. So I will come up here, I will enter my global admin account. Okay, so I'll come up here, I'll enter that connect.com, then click on authenticate. Then here it should request for my password. So you put in your password. So then you now come up here, click on sign in, and then it should bring out your question for your matching number. 1 second. Okay. 77. So here you now come back, click on your next. Now you can see it said the Microsoft Entra provisioning agent configuration. It said please preview the below. So you can see that. So by the time you now go back here, you come back here. By the time you now come back here, you click on your password reset, and then you come to on-prem integration. This particular one should be showing you the status as complete. Can you see that now? So that should be showing as one as complete. But if you don't do that, this will be showing that not configured. So this has to be configured. Now, once that is being configured, then this other one too. This where you have this your Microsoft Entra Connect Sync agent will be showing not configured because you have not go and check the right back password. So you now need to go back again to your on-prem. Now I can say confirm that to connect. Once you confirm it, you save it, and then I can now close this one. If okay, let me leave down. So here I can now come up here. This one here, you open the next. Let me close it so that you see what I'm doing. This is still okay. So I'll come back here. I'll open this my Microsoft Entra ID Connect. Okay, I'll open that. Now, once you open your Microsoft Entra Connect Sync, okay, so you now come up, you click on configure. When you click on configure, you now come up here, you now click on customize synchronization option. Click on that, you click on your next, and then come up here, you enter your credentials. Remember that this should be your global admin credentials. Okay, then you click on your next, then it should ask you for password. Then you enter your password. So you can see this takes a whole lot of things to configure for you to be able to configure your password right back successfully. So you can see how it is taking time, but it has to be done one step at a time. Okay, so once you do that, we talked about this one last. So you click on next, click on your next. I talked about this one, everything. Yeah, click on next. Then here you now come up here and check this password right back. You can see that now. I've checked it already. Like I said, I've done it so that to reduce time, and then the syncing time can be we can be able to test one or two things. So you see that now. So this must be checked. So once you check this particular password right back, you click on your next. Once you click on your next, it talks to it. Then when you come back to this place, this one status should be showing setup complete. But if you see that it is showing not enabled, then it means that you have not configured that password right back. Or if it's enabled and then you still come up here, still showing that not enabled, like I said, you have to come up here, you close this one, you close it, and you open it back, and then you resync it, and then it should work properly. Okay, now that we have configured our password right back, now what is the next thing? The next we now need to do now is we now go to our on-prem. We are still on our on-prem environment. Then you now come up here where you have your forest here, where you have your domain. You come up here, you right click. But before you do that, ensure that when you come to your advanced here, let me close this stuff. Let me close so you see what I'm doing. Now, normally you open your server manager, right? You come to your tools here and then click on your Active Directory, users, and computer. You click on that. So when you now click on that option, then you now go to your view and then make sure that this advanced feature is enabled. Okay, the advanced feature is what is enabled. So once that is checked, okay, so because of what you want to configure, then you now come up here and you now right click on this your domain, and then you now click on properties. Now when you click on your properties here, when you click on your properties, then you now go to your security. You go to security. Now, what are we trying to do here? Now, we want to configure the reset password, right lockout time, and then the right password last set. Okay. So when you click on that, the next thing you come up here, you click on your advanced. So it can be somewhat complicated, but once you understand the steps, it's quite very easy to do. Okay, so you come up here. Once you click on your advanced, the next thing you now need to do is to now click on this add, where you have these permission entries here. You click on add here. Now here you now come up here, select this principal, select a principal. You click on that option, then you come up here, you now enter your admin. Okay, enter your admin, and then you check. Then you come up here, you select your administrator. Like I said, I've configured it. I'm just trying to show you optional. So you click on OK. Now, once you do that, you come up here, you click on your OK, right? Then you now come up here under this principal type here, where we came up here to select all. You can see now it's showing you as what? Administrator. So this one, you leave it as that. Then applies to. Here you come up here and change this option, scroll down, and now select descendant users object, where we now need to go and select the reset password. Because if you don't select all this option, the password right back will not work effectively. Okay, so you come up here, and select this option. This is it. We have reset password. Okay, so this option must be configured, and we are configuring it under. We will have what? The administrator, which is this principal we select. Now, after doing that, then you now go under the properties and then look for right lockout time and right password last set. Normally, it should be checked by default, but at times it's not always checked by that. So you have to check that. So it's always, you can see, you have plenty option here. You can see there are plenty. There are very much. So you have to look at it one after the other. At times, always, if you have your bad eye, you have to strain your eyes very well. And remember that we are only looking for two options here: the right lockout time and the right password last reset option. That is what we need to check here. And then before we can click on final OK. So you scroll down, but I'm not going to click on OK when I see it. But at times, I also find it very difficult to check it because these options here are so much. I think we need to tell Microsoft to do a filter where you can search, and then type by search is very easy to do. But here you have to start going down, and then you have to look carefully and locate your right lockout time. Okay, so I'm just going to scroll down. If I don't see it, I'll click on OK, and I'll show you how I got it, where I got it. Right lockout time. So you have to be scrolling down. So this is the annoying part I don't really like it. So, but let's just see. Like I said, if we can't see it here because of our time, can't be wasting time. Oh no. Okay, I think I've seen. Oh no, this is right password last reset. So this option must be checked, and the other one is the right lockout time. So that option must be selected. So let me look for the other one. I hope I've not even passed it. I hope I've not go down again. So you can see those two options has to be checked. I think there's a documentation on all these from Microsoft, so I think I've passed that. It's up there. I will go to because of our time, I'm not able to be scrolling up, but you can see. So like I said, those are the two options you need to select: the right lockout time and the right password last reset. Okay, so those are the attributes that will be displayed on each of those users. Okay, this because when you are trying to troubleshoot. Okay, so like I said, if I can't find it here, it's there anyway, but because if you don't have a good eye, you have to strain your eyes and look for this. So I hope when I get my Microsoft MVP, I can bring it as part of my computer. Let Microsoft need to put a search here and then make it easy for people to locate an option. All right, okay. I will just bypass that. So once that is being able, so you just click on your OK. But I'm not going to click on OK because I've configured that already. So click on your OK. So when you click on OK, then the next one you now need to configure. When you click on your OK, by the time you click on this OK, let's say I'll click on cancel. So when you click on your OK, the next one again, you still come up here and click on your add, and then come up here, select principal, and then click on your administrator. Now we want to select the option of unexpired password. Expired word password. Now that unexpired password now, it allows a password to be able, so that when a password is being write back successfully, but if on on-prem environment, an option is being ticked that password expire, so it will clear that log. So if a user reset their password from M365 environment, a user coming from on-prem reset their password in M365 environment, and if that password has expired, maybe you have that option in your on-prem environment. Now, if they want to log in, there will be an issue. Why? Because of what? The unexpired password. But if this option is being selected, it will allow to clear that particular log whenever they are trying to reset their password and if the password has expired. Okay, so that's why we have to come up here. We've done the first one, which is the reset password, and then the right lockout, and then the password set time. So here you click on this OK here, and then come up here, click on your administrator here, click on it. Okay, then you now come down here under this option, you come up here and you now click on this objects. I think the option should be I think you select this object and reset. Should be this one, this object and this set. No, is it this? Let me go down. Okay, I think it should be this. This object and the sender. So you come down here, you now scroll down and then look for unexpired. Can you see now? Unexpired. So this one too has to be configured. This is quite straightforward. So you just click on that and click on your OK. Once you click on your OK, you are done, and click on then you now apply. But I'm not going to do that because I've done that before, so I don't conflict what I'm doing. Okay, so once you do that, you will now see it here. You see all those permission entries will now be located there. You can see where you have that password reset. You can see all that one which I've configured earlier on before, and then you have this is the unexpired password object which I select. You can see that entries has been there already. So I'll just click on cancel. So I'll click on cancel. So those are what you need to select here. These are what you need to configure here before you can now test and see if this password write back is working successfully. Now that I've configured, now let's now test for that particular user. So I'm just going back. I'll go back to my on-prem, the M365 environment. I'll go to that user. So this is the user here. Let me copy. Which password that? Okay, I think I remember the password now. I'll copy this and then I will open my private. So now I'll come up here. Let's assume I'll come up at Microsoft m365.cloud.microsoft.com. So I'll click on sign in here because I've given that user license, so I can sign in here, come up here. Now I'm going to sign in with their password I created on-prem. Okay, the password I created on-prem. But I think this will start asking me to configure the MFA and stuff like that, but we'll do it quickly. I'll just put in that password. So click on sign in. So you can see it's signing in with that password. So now here it's saying use a different account next. Let me see if I can skip that MFA because of time. Oh no, it's not allowing me. Okay. So here, let me just quickly configure this one. I'll come up here, United Kingdom. United Kingdom. Yeah, I'm just gonna put phone number next. I should receive an SMS. Now come up here. I will enter the code. 527170. I'll click on my next. So I hope it's not configuring. Okay. All right. Okay. Now this one now is trying to configure for me this particular one, which is my password reset. You can see here where we have the authentication method here, where we have security question we selected, phone number. You can see that has been configured. So that's what it's trying to configure for me, because I'm just logging with that user for the first time. Okay, so this has to be configured so that password write back can be set up. I mean, can be performed effectively when the user needs it. Okay, so here it's saying choose question. Here I'm saying in what city was your first job. I'll come up here. I'll just click on this. Then second question, what is your favorite food? I'll come up here and I'll put, I hope Dan will not see my favorite food. Yeah, it's rice. I love rice. All right. So here you come up here. The third questions, you choose in what city did you meet your spouse? Here I can come up here and then put my answer to that. Let me just say so I'm just going to put my answer, click on next. I hope I can remember this answer question. Okay, next. So that has been configured here. I'll now click on done. You can see now the security question here. You can see we configured that. So you click on done, and then that should sign me in. And Tango is not asking me for MFA now. So now this user, I've signed into this user in with my M365 environment. Now they can have, they can collaborate with users we have in the cloud environment. You can see here they can have access to Outlook and all the apps. You can see they have, because they already have license, because I've issued license to them. Okay, now this has been done. Now let's, for example, now this user now want to reset their password, and remember that this user is coming from the on-prem. Okay, now we've logged in with the user password. The password the user is bringing from the on-prem environment, because that password has synced. Okay, now they now need to reset their password now through using the word the SSPR. Let's assume he has forgotten the password, they don't know the password, and they need to reset the password. Now let me just close this. Let me log out. Just going to log out here. I'll click on sign out, and I'll close this browser. I'll open another private browser again, bring it in. Okay, so m365.cloud.microsoft.com, enter. So here now this user is trying to log in. Okay, let me get the, here's the name of that user. Okay, all right, so I'll copy. Now come up here, put in the email of that user. Next, now they are trying to log in. Now this user cannot even remember their password from on-prem again, but now they are now in the cloud environment, which is the M365 environment now, and they need to reset their password. So they don't need to now start calling the help desk. Let's say now this is already late now and they want to log in. Definitely the help desk will not be available to assist in that regards. Okay, so now all they just need to do is to come up and say forget what password, and then this should now take them, because of the SSPR, as long as it's being configured properly, then you should be able to reset their password without the help desk, okay, without the help desk. So here the email of the user, and then put the captcha here, 63xjh, and then I'll click on next. Now, can you see that now? I said, why are you having trouble signing? Forgot password. I do not know. Sorry, I know my password, but I can't log in. This one, I say forget password. I'll click on my next. Now, here is asking for the phone number. So definitely the phone number they use in registering. So they have to put in that phone number, which is very, very important also too. So they'll put the phone number and click on next. Thereafter, the next one. Remember that because of this, from what we have configured here, if you come up here on our authentication method, where you have method, we have phone, mobile phone, and security questions. So they have to give us that particular thing before what they can log in success, before they can reset their password successfully. So here, I hope the code should have been sent to that mobile phone. Let me have a look. Sorry, verification code. Okay, let me try again. I'm not sure it is sent that. Okay, that's coming now. So here they will not get that verification code. I put in the code there, 9652. I'll click on next. Once you do that, the next thing is the security question. So which means that they need to answer this, because that is what they actually initially configured. Okay, so they answered that when they are setting up which is this particular place here, where we said under registration here. Okay, we selected this option that yes, it has to. So that's why they're having all this. So here, in what city did you meet your spouse? I think I put Paris. And then in what city was your first job? I think here I put London. And then what is your favorite food? I think I put rice. So I'll now click on next. So you can see that once that security questions are being passed, then it will take them to the next one, which is now you can now create your password. So I don't need to go to the on-prem environment to reset, because definitely users will not have access to the on-prem environment to reset their password. Okay, so now we've synced those users to the cloud environment, and then we set up our SSPR, and then we set up the password right back, so that by the time they configure their password here, once they change that password, the same password, they can use that password to log in into what their devices. Okay, the same password can be used to log into their devices. So here I will just come up here 1 second. Let me look for a password to use. Spare me a second. Okay, so I'm just going to put passwords. You can see this password is quite different from the one we use for cloud, in the on-prem environment. So I'll click on finish. So can you see that now your password has been reset? So this user has now successfully reset their password without the help of the admin. Okay, without the help of the help desk. You can see that this is an on-prem user, and this user is in what department? I think is in sales department. This is the user here from on-prem. Okay, so now click on here to sign in, and then they come up here, put their email address, and then they should be able to sign in. 1 second. Copy that. So click on that, and then put in the password. That same password, you can see this is the same. That's the password we are using. The password we just said. Okay, so you can see that sign in. And then here it will ask you to verify your identity. Click on that. Yes, the phone number, a code will be sent. So you go there and then put in that particular code for. And then verify. So here you want me to set up my authenticator because I've not set up authenticator for this user. I just created, so I can skip that because of time. I'll just skip that because I've configured my conditional access policy to allow user to set up MFA. So I'll skip that for now. So yeah, I'll click on no, and then boom. Now we are in. You can see this user is now in with the password they set in their Microsoft 365 environment, which is through the password right back. Okay, so all users need to do is just ensure that the environment is being configured properly, ensure that the agents are running, properly, and then this should be successfully. Okay, so this is a user coming from the on-prem environment to an M365 environment, so they can reset their password and the password will also write back. All right, okay, so I do hope we have learned one or two things from this demo. Thank you very much. Thank you, Dan. Thank you, Frank, for this precious time you give to me.
Yeah, Frank had to run, so he asked me to finish up the meeting here. And OPME, great demo as usual. Thank you to everyone who joined us this week. Hal, thanks for stopping by. I know we had a packed agenda, and next week typically Frank queues up the speakers that are expected, and then a lot of times we don't have all the speakers we're expecting. I think this week we had everybody we were expecting, which was great. So thanks everyone for joining.
Not a problem. Always a pleasure to be here.
Yeah.
Thank you.
So I'm going to go ahead and end the live, folks, and we will see you next week, same time. This one, we've gone for, I want to say going average, we're at 2:45 on this one. So yeah, hopefully next week won't break any records in longest Azure and AI show.
Yeah, I think now we've been taking lots of time. Like
we used to try to do this in an hour, so we kind of accordingly with the number of speeches and or the time allotted to each speech. But it's a good problem to have, right? Too many community folks that are interested
coming into
That's nice
I think from late last year it has really been doing great because we're having a lot of speakers lined up, still moving, passing towards the usual time, which I just like what you said, is a good problem. It's weekends and then people just, even at least the recording is there. If no one has time to maybe stay all through, you can go back to the recording and then have a look. Yeah. Like last week I wasn't around, so I just made sure that today I have to be in to do as I promised.
Excellent. Well, I'll go ahead live here.
All right.
Take care, everyone.
Thank you.
See y'all next week.
Yep.
Thanks, Dan.
Thank you, Al. Thanks, OPME.
Thank you.